Okay, hey everybody, I'm out here to talk to you guys. I'm out here at my hot tub in my backyard. I want to talk to you guys about relative humidity. Relative humidity is a way of measuring how much water vapor is in the atmosphere. Now you have two different types of humidity. You have what's called absolute humidity, and that's if we were to take a parcel of air. A parcel of air is like a little package of air, and we actually counted every little water molecule inside of that parcel of air, and we got a number for it. To be honest with you, nobody ever really uses absolute humidity because it doesn't actually fit with how we understand weather and how we relate to the weather. What we use is what's called absolute humidity. Absolute humidity is a measure of how much moisture actually is in the air, how much water vapor is actually in the air, as compared to how much water the air can hold at that temperature. So that's a little bit complicated. It turns out that if it's hot, if the air is hot, it can hold a lot more water than when the air is cold. For example, I have 3 glasses right here. The reason I'm at the hot tub is I'm going to fill the glasses up with water. So here I've got this cup right here, and I filled it up, and you can see it's not 100% full. So this glass right here represents how much water a glass can hold at a certain temperature. So the volume of the glass represents the temperature. So wrap your head around this. So let's say that this glass is a nice, comfortable temperature, and there's a lot of water in it, so we would say it has a high percentage of relative humidity. In this case, we're looking at probably about 90% relative humidity. Now let's say it's a nice, comfortable temperature at the beginning of the day. As the day progresses, the temperature starts getting warmer and warmer and warmer. So I'm going to take this water and I'm going to dump it into this. This glass represents how much water the air can hold at this temperature. So notice I dumped all the water from this glass into this glass. Now you'll notice it's the same amount of water, so the actual humidity stays the same. But now we're down to about 60% of actual filling of this glass. So this would be called 60% relative humidity. Okay, so let's say the weather starts getting cold. We have the same amount of air, and now the weather drops down to, I don't know, close to freezing. So if the weather drops down close to freezing, I'm going to do this over here. Now what's going to happen is I'm going to pour this water in, and now we're going to hit 100% relative humidity. Okay, 100% relative humidity is what's called dew point. Dew point is a point of saturation. The air becomes too saturated, and at this point a couple of things will happen. I still have more humidity. I've got to dump this in, and if the air you can't go past 100%. If you can't go past 100%, that means the water starts falling out of the air. What does that mean for humidity? Well, you hit 100% relative humidity, then that means that the air can't hold it as water vapor anymore. So it turns into condensation. It turns into little droplets of liquid. And those little droplets of liquid you can find up there. Those clouds. Those clouds are examples of what's happening with condensation. These clouds that we're looking at right now, these are what's called cumulus clouds. These clouds that we are looking at right now, this would be a classic example of, it's a kind of warm day. Warm day. At the surface of the earth, the warm day can hold quite a bit of water, but it's not 100%. So it might be warm and kind of humid, not quite 100%. But if we start moving away from the earth, remember we said the earth is the thing that's responsible for heating up the earth. As we get further and further up into the earth, away from the earth, like an airplane flying into the sky, the airplane gets colder and colder and colder. Well, if the air is getting colder and colder and colder, then the air can't hold that moisture anymore. So what's happened up there in the clouds is this air that's being lifted up into the clouds is not able to be held at that temperature, and those clouds are heading dew point. The very bottom of the clouds is the dew point temperature, the temperature in which we have reached 100% relative humidity. And if there's more moisture in the air, what's going to happen is that moisture is going to keep pumping in, pumping in, pumping in, and it's going to start to rain. Okay? Now, you might have noticed that summertime and wintertime is a little bit different with your house. In your house, let's say in the wintertime, you might notice that in the house that your skin gets really dry. Everything's really dry in the house. Why is that? Well, outside it might be raining. You might be at 100% relative humidity. The same air that's outside is going to get pumped into your house. Well, if your house is at a nice, warm, comfortable temperature, then you're at a really low relative humidity, which means it's going to be a lot drier. Same air, but it's going to feel a lot drier in the house. The opposite is a problem that they have in, like, say, caves or cellars, places that are cool. So it could be a nice hot day outside, nice hot humid day. By the way, this is not comfortable. A hot humid day outside is 100% relative humidity. That means there's not a lot of room for us to add moisture to the air. And if there's not enough moisture in the air, your body starts to sweat. And as your body starts to sweat, it needs to evaporate to pull the heat away from you to cool you off. Well, that's not going to happen if the air is saturated. So you just wind up getting hot. This is why you hear people from the south saying, it's not the heat that'll kill you, it's the humidity. Well, the humidity is a problem. It could be 90 degrees in Louisiana with 98% relative humidity. And you try to sweat to cool off, and you're not going to cool off. But if you're in Arizona where it's dry and you're at 90 degrees, well then it's 90 degrees, but you're in the desert, there's very little humidity in there. You can sweat like crazy and that's going to cool you off. So 90 degrees in Phoenix versus 90 degrees in New Orleans, two totally different things. But let's go back to talking about what was going on with the wine cellar in your house. In your wine cellar in the house, you might be, I don't know, like 80% relative humidity. So not enough to rain, but enough to be warm outside. But that air gets pumped into your house, and when that air gets pumped into your house, you're going to hit 100% relative humidity. That's not going to rain into your house, but what it is going to do is it's going to condensate on the windows, on the walls, any kind of bottle that you have, and it's going to turn into water and possibly even drip down. And this is why places like cellars, the lower parts of the house, have such a hard problem with moisture. So that's it. That's what relative humidity is. I hope that was useful for you.